Hello everyone. Today I will be talking about heat capacity. When a system absorbs heat, its temperature increases. The increase in temperature is directly proportional to the absorbed heat. And when we remove this proportionality, we replace with equal. Our Q, which is heat, is going to be equal to C times change in temperature. In this case, our C is the proportionality constant and it represents heat capacity. The unit of heat capacity is joule per degree C or joule per Kelvin. The larger the C, the heat capacity of an object, the smaller the temperature rise will be for a given amount of heat. We have factors that affect heat capacity. The amount of matter, which is usually measured by its mass, affects heat capacity. For example, 200 grams of water will require twice as much heat to raise the temperature by 1 degree C as does 100 grams of water. The type of material also affects its capacity. For example, 1,000 joules of heat energy will raise temperature of 100 grams of sand by 12 degrees C. But for the same amount of water is only going to raise the temperature by 2.4 degrees C. Molar heat capacity is the amount of heat energy required to raise the temperature of 1 mole of a substance by 1 degree C. The specific heat capacity is the amount of heat energy required to raise the temperature of 1 gram of substance by 1 degree C. We can quantify this heat energy. The heat capacity of an object is proportional to its mass, the specific heat of that material. The amount of heat absorbed can be determined if we know the temperature change, mass, and specific heat. And this relationship is given as Q equals to M times the specific heat times temperature change. In this case, our Q is amount of heat and the unit is joules because it is an energy. M stands for the mass, which is in grams, and the specific heat is Cs, which is in joule per gram degree C. Remember, because of the unit of our specific heat, which is we have gram, whenever your mass is given in kilogram, please convert to grams. Our delta T represents change in temperature. In this case, we have to remember that our temperature change is T final minus the T initial. For example, how much heat is absorbed by a copper as it warms from temperature of a snow, which is -8 degrees C, to the temperature of your body, 37 degrees C. The mass of copper is 3.10 grams and the specific heat for copper is 0.8385 joule per gram degree C. So in this approach, the first thing we need to do is to write our relationship, which is Q equals N times Cs times delta T. Our mass is given as 3.10 grams, which is N equals 3.10 gram, and the specific heat for copper has been given, which is our Cs, for copper. 0.385 joules. And our TF, which is our T final, is given as 37 degrees from the question, and our T initial is -8 degrees C. If we plug this into our equation here, it's going to give us our Q is going to be equal to 3.10 grams times 0.385 joules times our TF, which is going to be T final, 37 minus -8 degrees C. So we have this going into this, and this grams goes away. So we're gonna have 3.10 times 0.385 times 45. So if we plug this in into our calculator, it gives us 53.7 joules. That is how we find the amount of heat absorbed by the copper. We have another example. Let's take a look. A 55 grams of aluminum block initially at 27.5 degrees C absorbs 725 joules of heat. What is the final temperature of aluminum? Given the specific heat of aluminum to be 0.903 joule per gram degree C. So, as usual, I want us to write our relationship, which is given as Q equals N times CS aluminum times delta T. Our Q is given to be 725 joules equals to our N is given here 55, and we have our CS given as 0.903 joules. Okay, remember our delta T here is T final minus T initial. So we have our T final, which is what we're looking for. We place it here. And our T initial is 27.5 degrees C. Right. So we have this goes away, and our T final so we have our T final to be, when we arranged this, is gonna be 27.5 equals 725 joules divide by 55 times 0.903 030. So this goes away and it gives us 14.6 degrees C. And we have our TF gonna be 14.6 degrees C plus 27.5 degrees C, which gives us 42.10 degrees C. So the T final becomes 42.10 degrees C. That is how we apply this relationship to solve problems. I hope we can use this to solve as many problems as we can find. Thank you for watching.